Hi class, recap muna tayo sa lahat ng na-discuss about how we calculate for the base shear. So, unang-una, nag-static analysis tayo. And then naka-classify ang static analysis for building structures and then non-building structures. So, sa building structure, ang nag-govern na section is 208.5. Under that section, meron tayong apat na formulas to follow to get the base shear for building structures. So, una, this is yung design base shear. So, we have V is equal to CVI over RTW. And then, we will compare this V sa Vmax. So, dapat ang value ng Vmax hindi lalampasan ng base shear na to. Yung sa number 1 formula. And then, we check yung V ulit sa Vmin. So, kung nasa zone 4 ka, dalawa ang Vmin mo. Kukunin mo yung greater na Vmin. Then, dapat hindi mas mababa ang design base shear natin doon. So, if lumampas ang design base shear dun sa Vmax, ang gagamitin na base shear, design base shear is Vmax na, yung value ng Vmax. Or, if mas mababa yung base shear, design base shear na nakuha versus yung sa mga minimum, doon tayo sa minimum na. Hindi tayo gagamit ng base shear na mas mababa sa dalawang minimum na to kung nasa zone 4. So, kung nasa zone 2 ka, ito lang ang V minimum na gagamitin. Yung number 3 lang. And then, kapag So, pag nakuha mo na ang base shear, kailangan mong i-distribute ito throughout the height ng building mo. So, to do that, kailangan mo munang first kunin ang period, which is T, natural period ng building mo. So, for regular buildings, pwede natin gamitin sis T method 1. So, pwede rin gamitin ang method 2 for mas accurate na period. So, number 2 formula is, yun nga, kukunin yung top na force, lateral force, yung pinaka mataas na force. Kung meron kang rooftop, so lalagyan mo siya ng FT. If your period is greater than 0.7. So pag less than 0.7 ka, 0 na yung FT mo. Pero kapag equal or greater than, kailangan mo kunin ang FT and ilalagay mo yan sa rooftop mo. Next, kailangan mo ding kunin ang Fx. So, Fx is for each floor level, pati sa roof deck. So, ibig sabihin, pag nandito ka sa roof deck, dalawa ang force na i-add mo. Una yung Ft, and then yung Fx corresponding for the roof deck. So, if 0 yung Ft mo, wherein T is less than 0.7 seconds, Fx lang ang meron ka sa roof deck. Next, so yun yung para sa building structures. So, next naman ay yung sa non-building structures. So, yung non-building structures natin divided into rigid and then meron ding non-rigid. So, para malaman kung rigid, dapat ang period niya is less than 0.06 seconds. So, ibig sabihin, mabilis ang oscillation niya, ang pag-cycle niya. Pag non-rigid, mas matagal ang isang oscillation niya. So, it's more than 0.06 seconds. So, non-rigid yon. So, kung ang building, ang structure mo is rigid, ito lang yung formula na kailangan mo. The base shear is 0.7 CAIW. So, wala kang Vmin or Vmax. Ito na agad yung base shear mo. And then, ang base share mo, syempre, i-distribute mo din dun sa structure mo. So, dun sa example natin, yung structure natin is merong pedestal and then may machine. So, i-distribute mo yung base share dun sa dalawa. Meron ka dito, meron ka dyan. So, if you call this as your object 1, this is your object 2. To get the fx for object 1, say f1, you will get yung weight ng 1. Ay, ba't yan ang ginamit ko? So, to get yung lateral force for object 1, so F1 equals yung weight ng 1 times mo yung nakuha mong base shear divided by yung total weight. Kapag kukunin mo yung lateral force para sa object 2, weight 2 ang gagamitin mo times base shear over total ng weight. So, nandito sila. Ito yung F2, ito si F1. So, saan siya i-apply? Dun sa center of gravity ng object mo. Then next, kapag non-rigid ang building, so, ito yung kailangan i-follow. Ang sabi, shall be designed to resist design seismic forces not less than those determined in accordance with Provision 208.5. Yung Provisions 208.5 are this one. So, applicable pa itong. So, let's copy this. So, ito ang formulas niya. Addition, meron kang formula din dito. Also, may sinabi pa siyang another formula sa item 3. So, how many formulas do we have in total? Meron tayong total 6 na formulas for non-rigid, non-building. Wait lang. So, meron tayong total na 6 formulas for non-rigid and non-building structures. So, note then na meron kang dalawang V minimum kapag nasa zone 4 ka, mga additional to. At kung i-observe mo, parehas tong formula na to. Ang pagkakaiba lang nila ay yung coefficient na 1.6 and 0.8. So, pwede mong bawasan yung 6 na formulas for non-building, non-rigid. Since lesser to, hindi mo na kailangang i-check ito kasi definitely this is less than dito. Mas malaki na tong formula number 6. So, we can just remove this from the list. So, just remember yung formula number 6. So, for the design ng non-rigid, non-building, kailangan mong kunin yung base shear, design base shear, and then i-compare mo siya dito sa Vmax. And then, tatlo na yung Vmin. I-compare mo siya sa tatlong Vmin. if you are in seismic zone 2. Tatlo yung Vmin mo. 1, 2, and 3. Pero pag mali. If nasa seismic zone 4 ka, tatlo yung Vmin mo. If nasa seismic zone 2 ka, isa lang yung Vmin natin. Just this one. Yung pangatlo. So, sa next topic na tayo, which is dynamic analysis. So, pagkuha ng base shear or lateral forces using spectral acceleration derived from the response spectrum. So, this is dynamic analysis na. So, response spectrum is a plot of the peak or steady state response, which are, yung mga responses are the displacement, the velocity, and acceleration. We have a series of oscillators of varying natural frequency that are forced into motion by the same base vibration or shock. So, that is yung kapag may earthquake. So, meron tayong mga accelerogram derived from instrument natin. They record yung acceleration due to the movement or shaking ng ground due to earthquake. So, from this accelerogram, makukuha yung acceleration ng earthquake versus yung time. Ito yung pinapakitang dinidifferentiate dun sa video na pinapanood ko sa inyo. Ini-integrate niya kada interval of time yung magnitude ng force, acceleration, and displacement kada change at kada propagation ng earthquake natin. So, nagkakaroon ng resulting graph na tinatawag na response spectrum. Tatlo ang pwedeng graph na ma-derive from accelerogram. Yun yung response spectral displacement, spectral velocity, and spectral acceleration. So, to get yung lateral forces dahil sa earthquake, using yung response spectrum, gagamitin yung spectral acceleration. So, this is an example of this one, itong graph na to. This is an example of yung spectral acceleration derived from spectral response spectrum. So, makikita nyo dito, along its x-axis is yung period, and then sa y-axis is yung g, or yung spectral acceleration niya. So, how do we use this para mag-design ng building or para makuha yung base shear? So, for example, on the figure, so, given yung spectral acceleration, and then given yung data, yung weight ng tank, pati yung content niya is equal to 240 kilonewton. Ang structural frame niya has a period of vibration na 0.3 seconds. Then, meron tayong spectral acceleration at point G. So, kung i-graph natin yon dito sa response spectrum na graph, yung period na 0.3 dito sa ilalim, from the x-axis is the period, and then versus yung spectral acceleration na 0.8, kung i-graph mo siya, so makukuha natin yung corresponding shear. So, if you remember, sa dynamics, meron tayong formula na ito. And then, since itong spectral acceleration is also our ground acceleration, which is SA, we can substitute yon sa formula ng FMA. And then, substitute din yung weight ng water tank, pati yung content niya, which is 240 kilonewton. That's the weight. So, kailangan natin is mass niya. So, kailangan natin siyang i-divide sa gravity, which is 9.81. And then, ang corresponding SA natin, per the graph, it's 0.8. So, G is 9.81 ulit. So, the equivalent force or base shear will be 192 kilonewton. So, ito siya. Nandito siya. Siyempre, applied siya dun sa center of mass ng tank. So, this example is what we call a single degree of freedom na structure. Dahil ang mass niya is nakalump on top ng tower or itong frame niya. And then, yung frame acts as one or unified na structure na may isang value ng stiffness lang. So, ang deflection niya or displacement or response lang niya is isa because you have one structure and then you have one mass. So, yun ang tinatawag na single degree of freedom. Ang displacement lang niya is isang direction lang. Either pa left na, to the right na ganun or pa left na ganyan. Next topic will be yung lateral forces using dynamic method for buildings pero using this formula. Kung wala kang graph ng spectral acceleration, you can use the following formulas. Number 1, T is equal to 2 pi over omega, where omega is the frequency in radians per second. In radians, kaya meron kang pi dito. Pang-convert ng radians. So, number 2, SA. This is the spectral acceleration and it is equal to yung omega or your frequency times yung spectral velocity, which is in meter per second. And then number 3, maximum relative displacement, SD, equal to the SV or the spectral velocity over ng frequency or omega. Number 4 is the base shear. It is equal to the K or stiffness ng structure mo times yung SD or yung maximum relative displacement. And then last, yung FMA nga from dynamics ito, and then also equivalent to F is equal to weight over gravity times yung spectral acceleration. So, example, given the following data, so for this tank, so meron tayong period of vibration. Period of vibration means ito yung T. Spectral velocity meaning ito yung SV, stiffness is K, and total weight na W. So letter A, get the spectral acceleration. So that is SA. Ano ang formula for SA? It is omega times SV. Ano to? SA omega times SV. So, how do we get omega? So, since meron tayong formula for period na 2 pi over omega, we can derive also yung value ng omega. So, our frequency or the omega is equal to 7.85 radians per second. So, we can substitute this value dun sa formula ng SA. So, we get the value of SA. dahil given naman si SV na 0.15. So SA is equal to 1.18 meter square. So since SA is expressed in terms of G, kaya i-divide natin siya ng 9.81 because G is acceleration ng gravity, 9.81. So ganito i-express ang SA, where G is yung ang 9.81. So kung makikita nyo dito sa spectral acceleration, ganun kasi ang notation ng spectral acceleration. It is in terms of G. So, kung gagamitin mo yan, yung SA na yan, kailangan mong i-multiply pa sa 9.81 na value ng gravity. So, SA is equal to 0.12 G. Next, letter B, get the maximum relative displacement. So, that is SD. Our formula for SD is SV over omega. So, given yung SV, na 0.15, and then our omega is 7.85. So, you get SD na 0.019 meters. So, displacement is usually denoted using mm. So, convert natin siya into mm. So, we have 19 mm na maximum relative displacement. Next is get the maximum base shear. We have formula din sa base shear. Stiffness times yung SD. Ano yung given nating stiffness? 15,158. So, letter C na tayo. So, 15,158 kilonewton per meter times yung SD na 19. So, hindi consistent yung units, so we need to convert this into meters. So, ang makukuha natin yung base shear is 288 kilonewton. That's the base shear. And then letter D, we need to get yung lateral force of the tank. So, meron din tayong formula na F is equal to MA to get yung force. So, FMA and then where A is SA, so we can use yung spectral acceleration to get yung lateral force. So, ano yung mass kasi? Mass is 2400 times anong spectral acceleration? 0.8. Ano yung SA? 0.12. 0.12 times 9.81 kasi nga naka-gravity pa yan. So, we get yung force equal to 288 kilonewton. And this force is applied dun sa center of mass nung tank natin, F. And then dito si base shear. So, as you can see, static naman sila or in equilibrium dahil equal si base shear dito sa force natin sa tank. So, Ganun pagkuha ng base shear. So, na-cover naman natin paano kunin ang base shear for building structures using static, pati non-building structures. And then, nag-dynamic analysis tayo for single degree of freedom lang na structure. Ito ay single degree of freedom. Ito din ay isang single degree of freedom. Yung example natin kanina. So, anong mangyayari kapag multi-degree of freedom? At ano ba yung multi-degree of freedom? So, nasa assignment. Nasa assignment yun. So, kapag multi-degree of freedom, meron ng iba-iba na response ang structure mo. Hindi lang isang sa isang position ang oscillation niya. Pwede na siyang gumanon, parang nagwe-wave na. So, ano example nun? Kapag 2-story house ka na, kapag 2-story house, meron ka na kasing lamp mast dito for your second story. And then what if meron ka pang lamp mast dun sa bubungan mo, like yung mga naka-roof deck. May lamp mast ka ng dalawa. So, multi-response na yung mangyayari sa building. Pwede nang ito pag ganon, ito pag ganoon. So, pwedeng ganyan ang response ng building natin. What more, dun sa mas matataas na story building. Kada floor, meron yung lamp masses. So, kada floor, pwedeng iba-iba, lalo na kasi ibang stiffness ng column dito, ibang stiffness ng beam. Iba-iba yung weight ng mga, ng mga floors mo. So, iba-iba ang response niyan habang tumataas ang building. So, yun yung mga multi-degree of freedom. So, ano ang examples naman ng mga single degree of freedom? Yun nga, yung mga tanks na merong support na masasabi mong isa lang yung stiffness. So, baka sabihin dito, naka-vertical brace. So, this is an example of vertical brace. So, vertical brace, pwedeng kunin kasi na isa ang stiffness ng buong height ng vertical brace na to. So, pwede mo siyang ilagay under ng single degree of freedom na structure. And then, ito yung lamp mast na dadalhin niya. Kasi isa lang din naman yung mast na isusupport niya eh. So, isa pa din ang displacement or maging response niya in terms of displacement, in terms of velocity and acceleration. Isang direction lang. So, ano pa ba? Ayun. So, but for this undergrad subject, magpo-focus muna tayo sa single degree of freedom. So, itong dalawang topic na to will be our last topic for our finals. So, ang final exam nyo, ang coverage is from non-building. Siyempre, yung non-buildings divided into rigid and non-rigid. And then, ito pang dynamic analysis, divided tayo sa using ng response spectrum na graph, and then yung dynamic analysis using yung formulas for dynamic method. Itong formulas dito. Also, I told you na syempre i-apply natin yung past lessons natin. Mechanics or yung strema, and then theory of structures, and konting dynamics. Actually, yung dynamics na yun, ito na yun eh. Itong FMA. So, paano natin i-connect? Siyempre, after getting yung base shear, I will ask you to design itong post na to. Ano ang most economic na steel double shape na 12 ang depth na kayang i-resist yung base shear in terms of its displacement and yung shear and yung bending stresses niya. So, I will give you an assignment. Ipopost ko sa, ang tawag dito, Canvas. So, it involves design na yan. So, syempre, paano papasok yung theory of structures? Yun yung determining ng displacement, di ba? Sa, kung determinate or indeterminate, may different ways tayo on how to quantify yung deflection. So, dun siya papasok. And then, extrema, syempre, isosolve mo ano yung shear stress, ano yung bending stress, or kung may actual stress ba, bearing stress. And then, you will design itong post na to against those stresses. And also, against dun sa minimum displacement. So, I will ask you na dapat ang displacement or deflection should be not greater than 4 cm, ganyan. So, ide-design natin. So, ganun yung assignment ninyo. And then, next meeting sa Friday, will be quiz na din. So, nagka-quiz na kayo dito sa mga non-building structures. So, next quiz nyo will be yung dynamic analysis using yung spectral response spectrum na diagram and using this formula, yung quiz ninyo. Itong dalawa lang. So, and then, isang assignment pa. Yung mga prelim exam nyo pala, nasa faculty, kung gusto nyo kunin, daanan nyo na lang sa faculty kapag break time ko.